Okay, so now we're going to go over section 5.5, which is factoring trinomials. Now, I do this different than the book for a few different reasons. One, because I've done it for so long, kind of realize students need to learn this a little different, especially if you're coming from a place where you're not comfortable with factoring. Okay, if you already know how to factor, that's fine. You can factor these however you want to. It doesn't bother me. I'm going to go over a singular way that just works every time. Okay, and then once we get to 5.6 tomorrow, I'll go over some like kind of quicker ways that work in certain situations. But the issue is that they're kind of a special way of factoring. This way that I'm about to go over will work for any trinomial if it's factorable. Okay, this will work for any trinomial if it's factorable. So now, and I need you to be so comfortable with factoring trinomials for college algebra. Okay, this has to be a reflex. Okay, where when you see one of these, you just do it. If there was any section that I needed to stress how important it was to do the homework, it's this one. Okay, where if you think you know it, do like 3 more just to make sure. Because when we get to college algebra, if you don't know how to do this, it's gonna snowball into kind of weirder, harder stuff because you just don't know a really fundamental foundational aspect of algebra, which is factoring. Okay, so let's look at what I'm talking about when I said this will work no matter what. And the way I factor trinomials in this section is called, it's going to sound familiar, factoring trinomials by grouping. So if you've done, and I know, if you're watching the video now, you might not have done the homework from 5.4 yet, but this is going to be a lot like 5.4. Okay, it's going to be very similar to 5.4. You need to do the 5.4 homework first so you know how to factor by grouping, okay, before you get to this section. Because really what I'm doing is I'm adding components to factoring by grouping, okay? So let's look at an example of how we do this, and it's just the best way to teach this is really through examples. Okay, let's look at this. So if we have, let's say 2x squared plus 11x plus 15. Okay, 2x squared plus 11x plus 15. So this is a trinomial, right? The whole goal of 5.4 is to factor this trinomial. Okay, the very first step, no matter what, step 1 is going to be to see if we can factor something out. 2x squared, 11x, and 15, there's nothing we can factor out of the trinomial. Okay, that was a 5.4 topic at the very beginning, right? See if there's a GCF. So check 1, no GCF. So now we're going to go actually to factoring this thing. If you know how to factor it already, just do it. If you know, look, I'll tell you, every single high school math teacher teaches this a little bit different, and they call it something a little different. Again, I like to use factoring trinomials by grouping. This is sometimes called the AC method. If you want to look it up later, or the bridge method. That's a bridge method. So those are the same thing. It's really just factoring trinomials by grouping. Okay, and I'm gonna do this slowly, and I'm gonna do it very deliberate to show you where it's all coming from. So 2x squared plus 11x plus 15. We've got a trinomial. We check to see it had a GCF. It doesn't. So the very first thing you're going to do, and it's why it's called the AC or bridge method, is multiply the first coefficient by the constant. So 2 times 15. And I'm going to write it on the side. I get 30. Okay? 2 times 15. And you get 30. And then you're going to go through 30 and see everything that multiplies to get 30. But the goal is to find 2 numbers that multiply to get 30 and add to get 11. So now I know hopefully you see you in your head, you're like, I know what it is. Just write down the answer, Mr. Shirley. And that's fine if you know what it is, but I want to show you how to kind of go about this. So 30 we know is 30 times 1, right? 10 times 3. Notice these don't add up to 11. 30 and 1, 10 and 3 do not add up to 11. It's not divisible by 4. Oh, we forgot 15 times 2, right? Still not going to add up to 11. And then we've also got 6 times 5. Hey, there it is. Now look, you could also make all these negative, right? Negative 30 times negative 1. It's not going to help us because 2 negatives add up to a negative. But you could write all these negative, and it would multiply to give me 30, positive 30, and add to give me a negative, though. We don't need that, okay? So I'm going to stop right here. I'm going to say, hey, it's 6 and 5. That multiplies to give me 30. And I'm going to do a quick check. 6 times 5 is 30. 6 plus 5 is 11. We found our two numbers, okay? So now here's the next step actually is going to create the factoring by grouping, okay? So what we're going to do is we're going to split apart the 11x. We're going to write this as 2x squared, and we're going to write it as 6x plus 5x. Right? We haven't violated any math laws. 6x plus 5x is just 11x, right? But what that does is it creates the factoring by grouping. Remember, the first step in factoring by grouping, or the first kind of idea of when to factor by grouping, is that we had 4 terms. Well, hey, guess what? We just we manipulated this trinomial into, I guess, a quadnomial, right? Into 4 terms. And then from here on out, we're just going to do factor by grouping. And if you did section 5.4 homework, this is going to be easy because this is the easier factoring by grouping. I think they kind of threw kind of tougher ones in 5.4. Okay, so let's do that. So I'm going to put parentheses around the first 2. Remember, you have to have a plus sign in between here. First 2 and last 2. I can factor a 2 and an x out of this first one. That leaves me with x plus 3. Oh, I need to factor a 5 out of the second one. Leaves me with x plus 3, right? These match, so I can factor the x plus 3 out, and it leaves me with the 2x plus 5. Okay? Leaves me with the 2x plus 5. Hey, I have factored this trinomial completely. Look, it went from 3 terms being added together to 2 binomials being multiplied together. And notice each one of these binomials, I know this is something from the lecture from 5.1 and 5.2. Each one of these binomials has a degree of 1. When you multiply them together, you get a degree of 2. Okay, that's throwing something else in there that's going to come back in college algebra. Okay, but the goal for this section is to go from a trinomial to 2 binomial factors. Okay, and this is how we're going to do it. Now, look, your book goes over a few different ways. There's a guess check method, there's a bubble method, there's a stair method, blah, 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 blah. I'm going to stick to one method for now. We're going to get this down, and then I'll show you a quicker way. But look, I'll tell you the quicker way wouldn't have worked in this example. Okay, you're going to have to do a different way than the quick method. It's this very special way of factoring in a special circumstance. Okay. Questions? So let's look at another one. Let's say I had, let's do one that looks a little easier. So x squared plus 10x plus 16. I need to do some negatives. I'll do a negative one next. So x squared plus 10x plus 16. Now remember, if x squared is by itself, you can write a 1 there, right? And I'm going to distribute the 1 times 16, just 16 there. And then I'm going to break this apart and try to find 2 numbers that multiply to give me 16 and add to give me 10. So 16 times 1, 8 times 2, right? And then we could do 4 times 4, but that doesn't help us. We need to add to 10. Well, that's 8 and 2. So I'm going to do x squared plus 8x plus 2x, right? Plus 16. So it creates the factor by grouping. We split the 10 apart into the 2 numbers that multiply to give us the 16, 1 times 16, right? And then add to give us the 10. So now I'm going to put the first 2 in parentheses and the last 2 in parentheses. Okay? So I'm going to factor an x out. Leaves me with x plus 8. Then I'm going to factor a 2 out, and it leaves me with x plus 8. Okay? And then notice these match. So therefore, I get x plus 8 times x plus 2. Oh, you know what? I didn't check the last one. I know what you're thinking. Mr. Sharp, how do I know I'm right? Well, you just have to multiply these through. Remember, we talked about that in section 5.1 and 2. If I wanted to check to make sure this was right, I just distribute the x. I get x squared plus 2x, and I distribute the 8. I get 8x plus 16. Add these together, and look, I wind up with the original trinomial. So therefore, I know this must be the correct factoring, okay? That must be the correct factoring. 8x plus 8 and x plus 2. Okay, great. So I want you to try this next one, and I'm going to keep going on it, but what I want you to do is just pause it. So I'm going to steal an example from the book. I need to do something like that. A second, hold on. Yeah, ooh, yeah. 3x squared. Actually, you don't have to pause it if you don't want to. Just watch this one. 3x squared minus 4. So if you want to pause it and try this one, pause it right now. Try it and then come back, okay? But 3x squared minus x minus 4. What makes this different is we got a minus sign here, and it kind of throws things off a little. We just have to be careful with negatives, right? So again, I'm going to start it the same exact way. I'm going to multiply the coefficient of the first times the constant. 3 times negative 4 gives me a negative 12. And now I got to be careful. So these two numbers have to multiply to give me negative 12. Well, let's take all the things that multiply to give me 12. So 12 times 1, 6 times 2, 4 times 3, right? Is there anything else? No, I think that's it. Now, but it's got to add up to negative 1. And one of them has to be negative. So think about this. Either the bigger number could be negative, or the smaller number can be negative. Right? But to add up to negative 1, look, this would add up to negative 11, negative 4. Oh, there it is. Negative 1 right there. Negative 4 and positive 3. Multiplies to give me 12. Look, I'm always going to do a quick check if I've got negatives going on just to make sure I've got the right two numbers. Okay? Negative 4 times 3 gives me negative 12. You multiply it. Negative 4 plus 3 gives me negative 1. That's definitely the two numbers I need. Okay? So now I'm going to crack this apart. Now, look, I'll tell you, if I've got a negative and positive, I am going to make the first number I'm going to put the negative first because it makes the positive where it needs to be. So I get 3x squared minus 4x. I'm just going to put that directly in parentheses, plus 3x minus 4. Okay? Notice all I did was separate the negative. These two added together would still give me negative 1x. I have not violated any math rules. Okay? And then now I'm going to keep going with my factoring, right? I'm going to keep going with factoring by grouping. So I can factor an x out of this first term, and it's just 3x minus 4, right? Oh, look, good. I haven't got to an example like this. We don't need to factor anything out of this one, right? So if I don't want anything to change, I need to just factor a 1 out. Okay? I'm going to factor a 1 out. So in doing that, it keeps the 3x minus 4 the same. So when I factor out the 3x minus 4, I'm left with x plus 1. And I'm going to definitely do a quick check on this because of the negative sign. So I'll bring out the red marker again just so I kind of show you I'm checking it. 3x times x, that's 3x squared. 3x times 1, that's a positive 3x. Negative 4 times x, that's negative 4x. And then negative 4. Add these together. So they're like terms. Oh, yeah. I get what I started with. So therefore, this is the two factors. We've factored this trinomial. Pretty cool stuff. Okay. Pretty nifty. Okay. You need to pause it there for a minute because you're writing. That's fine. Just pause it and then come back. I know I'm kind of zooming a little bit, but I'm excited. This is one of my favorite sections to go over. Okay. So let's look at one that actually I'm going to tell you up front. We got to factor out in the GCF. So let's say I'm going to steal this example directly from the book. Now we've got 5x cubed minus 30x squared minus 35x. Okay, kind of different. We got a 5x cubed here, right? That's different. All of them have been squared. But notice if you look at all three of these terms, the first step in any of these factoring questions, any of them, period, no matter what, the very first step is going to be, can you factor a GCF out? Okay, well, I can see that they're all divisible by 5. So I can factor a 5 out. And then I've got an x cubed, x squared, and an x. I can factor an x out. They all have at least an x. And that leaves me with, okay, if I factor a 5 and an x cubed out, that leaves me with x squared. Factor a third, so that's going to be negative 6. Factor one of the x's out. And then lastly, 35 divided by 5, that's minus, so minus 7. And I factored the x out. So it leaves us with a trinomial. Okay, it leaves us with a trinomial with a degree of 2. So what I'm going to do now is actually just focus on that x squared minus 6x minus 7. I'm going to see if I can factor it. Okay, I'm going to see if I can factor it. So remember, there's a 1 here. So 1 times negative 7. Oh, that'll be nice. Negative 7 is prime. So it's got to be either negative 7 times 1 or 7 times negative 1. That's it. Well, to get negative 6, we need the negative 7 and the 1, right? Multiplies to give me negative 7, adds to give me the negative 6. So I'm going to split that apart. I would get x squared minus 7x plus 1x minus 7, right? Adds to give me the negative 6, negative 7x plus 1x, negative 6x. Multiplies to give me the negative 7, so I'm going to put parentheses around that. I need to factor an x out here, leaves me with x minus 7, right? Again, just like that one we just did, I don't need to change anything here. This is already x minus 7. So I'm going to factor a 1 out. Leaves me with x minus 7. So I'm left with x minus 7 times x plus 1. Now, do not forget, at the very beginning, you factored out a 5x. So we've got to write that first. 5x times x minus 7 times x plus 1, right? 3 factors. Now, this one had 3 factors, and the degree was 3. Interesting. But really, what's happening is each one of these factors has a degree of 1, right? Kind of neat. Not a coincidence. Doesn't matter for developmental algebra 2, though. It will matter for college algebra, okay? So I'm going to give you another one like this, and I want you to try it. Again, you can hit the pause button and work this one out, okay? So let's look at it. 2n squared, I'm stealing this one from the book too, minus 38n plus 40. Okay, so hit pause real fast, and then take a minute and try to work this one out. Notice it's got a GCF. There's the hint, okay? Notice it has a GCF. Okay, so back from the pause, let's see if you got frustrated on this one. So notice they're all even, so I'm going to factor 2 out. So I get n squared minus, is that 17? Nope, that is 19. N plus 20, okay? N squared minus 19n. Oh, you know what? I wrote this down wrong. Oh, that's fine. Let's see if it keeps going. So n squared minus 19n plus 20. So can we factor this? Well, let's see. So now I'm going to write, don't forget the 2 for the very final answer. N squared minus 19n plus 20. Multiply those, I get a 20. Well, that's either going to be 20 times 1. It's got to add up to negative. We haven't really done one like that. So it's got to be 2 negatives. But that adds up to negative 21, not negative 19. I couldn't do 20 times or negative 20 times 1 because that would multiply to give me 20 or negative 20, not positive 20, right? Negative 20 times 1. It adds up to negative 19, but it doesn't multiply to give me a positive 20. Well, and the other ones aren't going to work. I mean, 10 times 2 is too low of a number, right? And then 5 times 4. You know what? I don't think this is factorable, okay? And it's not, and that's A-okay. Now, we did factor it, so your answer would be 2 times n squared minus 19 plus 20. That is your answer, okay? But the trinomial is not factorable, okay? The trinomial there is definitely not factorable. So kind of goofy, but that's just how it is. Okay, so let's look at a few more that definitely start out different, but in the end, we're going to do the same thing. We're going to factor these by grouping. So let's look at, this is an example in your book on page 385, actually. This is 16 x squared plus 24xy plus 9y squared. Oh my gosh, these are bigger numbers. But now notice we've got two different variables going on in this one, and that's not a big deal. We just have to be consistent. So when we split apart this 24, we're going to keep the xy in both terms, because when we add it together, we get the 24xy. I'm going to see if I can factor. Man, I can't factor anything out, can I? 16 and 9 don't have common factors. And then there's not an x or a y through all three parts. So I'm going to multiply the 16 and the 9 together. It's going to be a big number. Oh, man, I gotta use a calculator. 16 times 9 is 144. And I'll tell you, 144 is a nice number. I guess I'll use the whole page. 144 is a nice number because it has a ton of factors. Now, our goal is to get 24. So if you're like, man, I have no idea where to start. Now, I've got my cell phone out here. So I'm going to kind of show you where I go from this. 144, I'm going to divide it by 2. 72. So I know it's 72 times 2. That's not going to help us out, right? I think it's divisible by 3. So 144 divided by 3. 48. That's still not going to help us. We got to get down to 24, right? 48 times 3. Man, this thing I think is also divisible by 4. 36 times 4. Still, we're not low enough, right? That adds up to 40. Not divisible by 5. Let's see if it's divisible by 6. Yeah, 24. We're getting closer, right? I don't think it's divisible by 7. What about 8? Clear. 144 divided by 8. 18. Is that? Nope, that adds up to 26, right? Yeah, that adds, 26, not 24. We're good there. Is it divisible by, so wait, that was 8. So let's do 9. 144 divided by 9. 16. Oh man, we're almost there, right? 16 plus 9 is 24. Okay, it's not divisible by 10, right? 11, nope. Let's do 12. Boom, shakalaka. It's 12 times 12. That adds up to 24. So it took us a minute to get there, and sometimes it just does, okay? So let's separate the 144 into 12 and 12. So we get 16 x squared plus 12xy plus 12xy plus 9y squared. So be careful that you look, when you add these together, 12xy plus 12xy, they have to have the same variables that when you split them apart, okay? And now we're going to put parentheses around the first two and the last two. I can factor what, a 4x, yep, out of the first one. And I'm left with 4x, that's 4 times 4, 16, x times x is x squared. 3y, right? I factored the x out, but I'm left with a y. The second term, 12 and 9, I can factor 3 out. I can't factor an x out because the y squared doesn't have an x, but I can factor a y out. And I'm left with 4x plus 3y. I got that a little close there, didn't I? So now check, these match, right? So I'm going to factor them out, 4x plus 3y. Hey, you notice on this one, we're left with 4x plus 3y. Okay, that's just a kind of a cool coincidence. We have the same factors in both. So you can write this as 4x plus 3y times 4x plus 3y. Or you can write it as 4x plus 3y squared. Either way is okay. On a test, I'm not sure which one it does, so know that they're the same thing, okay? 4x plus 3y times 4x plus 3y, of course, is 4x plus 3y squared. Okay. Okay. Let's see if there's anything else. That's about it. I mean, we've done a lot of examples. This section actually is, if you, I mean, I just need you to know, of all the sections in developmental algebra 2, in this kind of pre-college algebra class, this is one of the most crucial sections. And for later on in this class too, it's not just the college algebra, it's the moving forward. So for homework, this is 5.5, page 388 is where it starts. I need you to do 1 through 33, and then 43 through 61. And then I'm going to get kind of picky and choosy here. Let's do 69. I'll say that. Hold on. 69 through, let's do a comma. 69 through 75. And that'll work. We'll do that. So just do all those. That's odd still, just like the last one. So 1 through 33, 43 through 61, and then 69 through 75, odd. Okay, great. So the next lecture, 5.6, we'll go over special factoring. And some of these we can do quicker. Not all of them. I'll tell you, this one I don't think we can do any quicker. Okay, but some of them are quicker, and then we're going to get kind of different factor or kind of polynomials that you can do in like 2 or 3 steps instead of having to do all of them. But we have to know how to do this because not all of them are special factorings. Okay, so I will see you guys in the next lecture.